live. And it says we're live. Excellent. Okay. Wow. We have 1 week. 1 week until your AP test. I got an email from Miss Gerke. This is specifically for those who inquired about transportation, which I know there was a handful of students in this class who did that. So I'm just going to read her email. She says, "Hello, AP students. You are receiving this email because you've indicated that you will require transportation for your AP exams next week. Obviously, us being Tuesday, May 25th. Please be aware, due to the 12 o'clock start time of these exams and their conclusion being after our regular dismissal, the transportation department will not transport you back to BHS following your exam. You must get your own ride," and this is hilarious, "or walk after your exam is over. Also, if you no longer need Barnegat School's transportation," she put in bold, "if you are getting your own ride to and from the exam, please let us know right away so the bus is not waiting for you. Please reach out with any questions and good luck on your exams." Yeah. So I wouldn't be mad at Miss Gerke for that one. I honestly think this comes down to some red tape at transportation. But that's the circumstances that we're kind of faced with. I think it would be hilarious if, we kept the request in for transportation and then people kind of got their own ride and let transportation kind of hang out there. But that's just me. I'm not going to tell you what to do. But that's the email that I got. It says hello all AP students, but it's only addressed to me, Geddes, Fonseca, and Purpury. Oh, you did? Oh, my bad. Okay, there we go then. Yeah, I mean, I'm just saying it's only addressed to us. She must have sent it separately. So, but I just wanted to make sure you guys were aware of it just in case. But like I said, I wouldn't blame Miss Gerke on this one because she was just as irked as the rest of us were when she heard that information. So, yay for excitement. Okay. As for today, just as a reminder for those of you in the chat, I can see your comments starting to pop up. Thank you for that. Please make sure you're leaving a comment in the chat. That'd be great. My goal today is to review linear regression. I have something set up that I'm going to be sending you via Google Classroom in order to kind of remind yourself and to push yourself as to, wait a minute, how do I do this stuff with linear regression? Kind of, so to speak. So what I'm going to ask you to do is kind of twofold for those of you in this classroom. Number one, if you don't have the Chromebooks out and open, I would strongly suggest that you break those out and log on because what I'm going to be sending you is a PDF via Google Classroom. That'd be great. And second, because again, yes, we are going to be using these handheld calculators next week, I figured, again, it would be good practice to be able to enter the data in a handheld calculator opposed to the computer calculator, because with the handheld calculator, you might be able to do this a bit faster, a bit swifter if need be, which we will talk about. So what I'm going to ask, obviously, besides the Chromebooks, for the first couple of rows, if you'd be so kind, if you don't have a handheld calculator, please come get a handheld calculator. They should be disinfected from last time because no one has touched them since you guys, just so you know. So no one's touched them since last Friday. Next couple of rows, if you need a handheld calculator, go get a handheld calculator. You see Governor Murphy put out an executive order about next year's school year. Some people saw it, yeah. He said that next year everyone will be in person full time. Obviously, I would assume there are going to be some exceptions to that rule, but we'll see what just happens. Yes, so everyone has a handheld if need be. That would be fantastic. Okay, good. 1,000 times good. Okay, here's what I'm going to send you. I'm going to post this on Google Classroom right right. Click PDF for today. Post. There we go. There's a PDF that I just posted. It looks something like this. Oh, whoever can get there first. I'll get there first. Yep. Oh, I'm so close. Okay. They have the Chromebooks, and if you need a handheld calculator, yeah, I have them there. They haven't been touched since Friday, and we disinfected them when we put them back in. So, but yes, there is this free response question from the 1997 AP test. Now, this free response question in particular, if you haven't noticed, is number 6. Being that it is number 6 on the free response questions, because there are 6 total. The first 5 are regular free response questions that they recommend that you take about 12 minutes on. And then there is an extended free response question, which they recommend about 25 to 30 minutes. You can even see it right here. Spend about 25 minutes on this part of the exam. And that's exactly what I would like you to do. Now, obviously, I can go over every aspect of this problem and kind of explain what is expected of you, but I want you to pretend like it's just you and the test. It's just you and the test. No one can help you now. Now, this question that I'm giving you today, this is not graded. I am not collecting anything. Turn around. Here we go. I had to turn around so I didn't get tangled in the cord. That would have been weird. We have our Chromebooks out to look at this problem. Oh, look, he just kind of shooed me out of the way. Anyway, we have the Chromebooks out to look at this problem, and if you need a handheld calculator, they're up here. They should be disinfected from last week. But yes, this question, I want you to pretend like it's you in the test. It's not graded. I'm not collecting anything. I just want you to be able to see what you can do with it. I will give you one basic recommendation when doing this problem. Something that I learned through a little bit of trial and error when I was doing this problem myself. When it comes to the years, I highly recommend that if you want to replicate the data that they give you later on in this problem, don't type it in as 1990, type it in as 90. Don't type it in as 1993, type it in as 93, etc. Type it in as the 2-digit year. That is what they did when they were doing their data. This problem is about re-expressing your data. This problem is about re-expressing your data. And you're going to see that on some of the digital outputs that they have later on down in this PDF. What we're going to do is I'm going to give you a block of time to attack this problem to the best of your ability. I have the grading rubric for this that I'm going to send you, but then I'm going to send that to you, but then we're going to go over the problem together. More importantly, in that grading rubric, I believe there are some sample student responses from 1997 that we will talk about and we will look at on the big screen. So the time is approximately 7:29. I want to give you, now again, I'm going to kind of estimate this. It's going to be between 20 to 25 minutes on this problem. Read carefully. I would strongly suggest that anything that you're doing for this problem, write it out on a separate sheet of paper. Again, I'm not collecting it. This is for your own validation to see what you can do with this problem. Begin reading and begin. goes. right. That's about a little less than 20 minutes, but I wanted to kind of move this thing along a little bit. First, let's talk about what this problem is asking, and something that really, really irks me about the problem. You are planning to sell a used 1988 automobile and want to establish an asking price that is competitive with that of other cars of the same make and model that are on the market. A review of newspaper advertisements for used cars yields the following data for 12 different cars of this make and model. You want to fit a least squares regression model to these data for use as a model in establishing the asking price of the car. Did it irk anyone else that the prices were not given in like chronological order? It irked me so much. I'm like, whatever, cool. But just for the sake of argument, and I did this because I wanted to compare what was going on. I entered in my data into my calculator. Just stat edit, you can enter in that data right there. And as I suggested, you put in the 2-digit year because that was just my trial and error. I actually entered this data in multiple times yesterday, trying to be like, okay, well, which one is the correct one that they kind of did, because I wanted to be able to do it myself, but it needs to be the 2-digit year. The computer printouts for 3 different linear regression models are shown below. Model 1 fits the asking price as a function of the production year. Model 2 fits the natural logarithm, ln, of the asking price as a function of the production year. And Model 3 fits the square root of the asking price as a function of the production year. Each printout also includes a plot of the residuals from the linear model versus the fitted values, as well as additional descriptive data produced from the least squares procedure. So looking at Model 1, and obviously you can see that a bit better on your PDF. That's why I sent it to you, so that you could see it a bit better than what's up on the screen. But on the left graph, that is just flat out the scatter plot. And they got a regression equation, and you can even see, oh yeah, they have a little r squared down there for me, which is nice. But then they also give you the residuals. It's like, the residuals, I mean, they kind of look like a pattern. They kind of look like a little bit of a V shape or kind of a weird U shape. I'm not really sure. But that regression, I don't really know. Let's see what happens. Model 2 is where they took care of the natural log in order to refit the data. And you can see the natural log of the price happening right here, ln price, in which when they did the residual graph, it looked a little bit more scattered, which is nice. They're trying to make this thing look straight enough. They're going up and down the ladder of powers, is what they call it. And then Model 3, you can see the square root of the price happening right here, in which, yes, again, the residuals do look a bit more scattered. And as they're doing this, I mean, their R squared is improving. Let me see, because I know the first one was in the 80s. And then Model 2. Oh, Model 2 was actually 94.6% for the R squared. Good for that. Well, let's see what happens. Let's see what the questions are actually asking. They want you to use Model 1 to establish an asking price for your 1988 automobile. I'm like, okay, I could do something like that. Let me get this little marker going on here. Let me scroll back up and get down the equation for Model 1. So in the Model 1 equation, y hat is equal to negative 58.1 plus 0.719x. And for all of these, x is the year, and the y hat is the predicted price. And they want the 1988 automobile. Let me zoom out on that. Here we go. So again, just for the sake of argument, y hat is the predicted value. You are allowed to plug in a year. So let's plug in a 1988 into that equation. I'm going to use their numbers, negative 58.1 plus 0.719 times 88. Huh. What's going on there? I got 5.172. That's the price of the car? Where? There we go. I just wanted to be sure, because here's the thing. Honestly, I'm not even kidding you. Someone would get that number and they would write down $5.17. They would. I guarantee you. Think about it. You're taking a 3-hour test, and this might be the last question that you're faced with. If you only have like 5 to 10 minutes to go, are you really going to be thinking straight? I don't know. Just giving you the full heads up. But yes, the asking price, I didn't even mention that when I read this thing. The asking price is measured in thousands of dollars. Instead, I brought your attention to the chronological order of this thing, which is just awkward. So if this is measured in thousands, boom, $5,172. $5,172. That seems like it would answer the first question. Yeah, use Model 1 to establish an asking price. Cool. That's A. Let's go to B. B wants you to use Model 2 to establish an asking price for your automobile. So let me write down the equation here. Now, this is going to be a little bit weird. It's going to be a little bit weird, but I'm going to actually write it down a little bit differently than what it's written on this actual printout, just slightly differently. Double checking my numbers. Boom. Here's what I wrote down for part B. It's natural log. So it's ln parentheses y hat in this case. It's going to be almost exactly the same type of calculation, except when you get to the end, you're going to have to take care of that ln, which I'll remind you how to do that on the calculator. In Algebra 2, you guys spent a ton of time with exponentials and logarithms. Cool. Just by mentioning those words to get that chill down your spine. Yeah, there you go. There you go. It wasn't that bad. I enjoyed the chapter on exponentials and logarithms in Algebra 2. I digress. Let me plug in that 88. If I wanted to, I mean, I could just, I could say let x equal 88 for the car, or let x equal 88 right here. The interesting thing is, if I didn't say anything to you, about the 2-digit year, look what might have happened. If I didn't say anything to you about the 2-digit year, look what might have happened. Is there anything on this free response that mentions that it needs to be a 2-digit year? No. That's actually really interesting. Because like I said, I figured that out just by pure trial and error, because I wanted to replicate the regression equation and the R and the R squared and all that stuff. But there actually isn't anything on here that indicates a 2-digit year. That's so sneaky. That is very sneaky. Anyway, back to this. Letting x equal 88. Move that over a little bit. Zoom into my calculator. There we go. Negative 14.9 plus 0.185 times 88. Boom. I get 1.38. But here's the thing. I'm not about to convert that yet. I'm not going to convert that to thousands of dollars yet. Because if we go back to the actual calculation, ln of y hat equals 1.38. First, I got to get that natural log off of the y hat. And if you remember back to your Algebra 2 days, there are multiple ways of handling this, by the way. There's multiple ways of handling this. You could convert this to log base e, and if you know how to convert logarithm form to exponential form, you could do that. But in my opinion, the fastest, most straightforward way to do it is this. E to the power. Because if you do an exponential that has the same base as the logarithm, they will cancel each other out. E is on your calculator. E to the 1.38 gives me y hat at 3.9749, I guess, if I dot, it kind of keeps doing that. If I multiply that by 1,000, it should give me $3,974.90. That would be an appropriate answer for this problem. This is where they kind of mess you up. This is where they mess you up. They're kind of bringing back in your algebraic skills and knowing how to handle these types of equations. Move that up a little bit so people can see it. But that is what you have to do on part B. On part C, let's see what they want. They want me to use model 3. Let me write out the equation for model 3. After we do this, I want to remind you of the ladder of powers and what that actually looks like. Just double checking these numbers. Good. Here's model 3 for part C. Again, I like writing it out like that. It's the square root of the y hat. I already indicated what x and y were at the beginning. I said x equals the year and y equals the predicted price. If you want to put it, in thousands of dollars of the 2-digit year, that's up to you. But if I'm going to do that here, negative 13.3 plus 0.176 times 88 gives you this number, 2.188. But again, that is not our answer. That is not our answer. The square root of y hat equals 2.188. I'm still going to have to square it in order to get the actual predicted y hat value, which is 4.78734. I'm going that far because in a moment I'm going to have to multiply it by 1,000, which would give me the actual price of $4,787.34. There's a lot of moving parts to these problems. A lot of moving parts. Interpreting those regression outputs is important, especially if they re-expressed their data. Just for the sake of argument, off to the side right here, I know there's more to the problem, but off to the side right here, I'm just going to remind you of the ladder of powers. The ladder of powers is used to re-express data to make it look more straight. I'm going to put a 0 there, but I'll define that in a little bit. Oh, I missed one. There we go. Hold on. There's a 1/2. There we go. Now the 0. Now the negative 1/2. Then the negative 1. And if you wanted to, you don't have to go this far, but you could go as far as -2. Technically, you can go farther up or farther down. This is actually a square root. This is a logarithm, which, you don't have to use log base 10, but log base 10 typically is one of the most common ways to do it. Of course, in this problem, they used the natural log. This is the inverse 1 over square root. And this is just the 1 over, I'll put in the variable x and 1 over x and 1 over x squared if need be. But this is the ladder of powers, where you would re-express your data, rerun the regression to see if you got a better residual graph. As a reminder, I know you're all thinking it once I ask the question, but if I were to ask, what are you looking for in a residual graph? What is it that you're looking for in a residual graph to make sure that you have an appropriate model? No pattern. You want it to be as scattered as possible. Now, just for the sake of argument, I just kind of walk you through this procedure right here on the calculator. You all have the handheld calculators. I just kind of want to walk you through this. First of all, I entered my data right here. It'll focus in a moment. There it is. I entered my data into list 1 and list 2. I turn my diagnostics on. You got to go through the catalog, go down to the Ds, turn your diagnostics on, because if you do that, then it will actually calculate the R and R squared. I can run a linear regression if I hit Stat, tab over to Calc, and go to LinReg. Now, this is the interface that they actually give you. This is the interface that they give you on the 83s and this particular 84. I'm doing L1 and L2. If I don't tell the calculator anything, it will automatically believe that I'm doing L1 and L2 for the linear regression. And these are the numbers. These are the numbers that popped up on the Model 1 output. These are the numbers that popped up on the Model 1 output. Now, supposedly, they went about re-expressing the data. Well, let's actually look at the residual graph. Again, I want to walk you through, how do I even look at the residual graph? Well, if I hit second y equals, turn on that first plot, it's already set to scatter plot. Go down to L2. I want to look at the residual graph. You have to hit second stat in order to get to what is known as your list of lists. Second stat will bring you to your list of lists, which your resid is automatically there because you turned your diagnostics on. Zoom 9, there's the residual graph. And that's the residual graph from Model 1. And they're like, oh, we don't like that. We want to re-express our data. Now, I'm only going to do this like once for now, and then we'll see what the rest of the questions are doing. But they re-express their data using a natural log. So here's what they did. Here's legitimately what they did. Stat, edit. I go over to L3, where I go up and highlight L3. They did the natural log of the y values. So ln of L2. Oh, it's frozen. There it is. Natural log ln parentheses L2. If I type that in correctly, it'll populate that list. Now, again, this is what you have to kind of get your head wrapped around with the handheld calculators. If you don't have the same interface, you have to rerun that linear regression. But in rerunning that linear regression, you have to tell the calculator what to do. So I'm going to type in L1, comma, you have to put that comma in, L3. Because I re-expressed the data in L3. This is Model 2 using the natural log. If I hit that, it will give me the numbers, the exact numbers that popped out of that model, that were in that model output, the 0.185, the negative 14.9, it's all right there. But that's how you can re-express your data. Now, because you reran the linreg, the residual graph was updated. So if you zoom 9 it one more time, it will give you the updated residual graph. If I actually go back to Model 2 right here, here's Model 2. I'm circling my mouse around it compared to the calculator. It's exactly what they did, just for the sake of argument. If I go down a bit farther, let's see what the next question actually is. Describe any shortcomings you see in these three models. Describe any shortcomings you see in these three models. Now, obviously, this is more of a subjective stance, but one of the most glaring shortcomings that I see is the fact that they never quite got rid of that pattern-looking shape in the residual graph. They never quite got rid of that pattern shape in the residual graph. It's still, I don't know, looks like the Big Dipper. Just saying. Would I have to say one for each graph? I don't know. I guess we'll see when we see the student responses. And then it says to use some or all of the given data to find a better method for establishing an asking price for your 1988 automobile. Okay, I can establish a better asking price. Let's re-express the data. Let's re-express the data. Now, if you know how to do this swiftly, this shouldn't take you much time at all. But I'm going to re-express my data. They've already used square root and ln. Let me try a different one. Let me just try squaring it. See what happens. L2 squared. I don't know. Let's just see what happens. I don't know if this will work. Let me rerun the linreg. Oh, it's frozen again. Let me rerun the linreg with L1, L2. All right, zoom 9. Oh, definitely not. Absolutely not. No, that is more of a pattern than the other ones combined. Okay, stat, edit, go up to L3. I can clear that up if I want to. Let's try 1 divided by the square root of L2. Let's see if that works. All right. We'll try to rerun the linreg. Let me zoom 9 it. Looks like birds flying in a V shape. I mean, that could work. I don't know. Stat, edit, go up here, clear that out. 1 divided by L2. Let's see if that gives me anything. 1 over x. I'm going down the ladder of powers. Rerun the linreg. All right, zoom 9 it. That is a little bit better, actually. Yeah, that is probably, I mean, going left to right. Although at the end, it does have this kind of curvy thing going up. But that is probably the most scattered that I've gotten so far. I'll try one more with x squared. Let's just see what happens. 1 divided by L2 squared. Rerun it. Zoom 9 it. No, that's more of a pattern. Yeah, 1 over x seems to be the best kind of situation I got going on here. So I'm going to write some stuff out once I get this thing and inputted one more time. There we go. So let me write down some of that information. The best model that I was able to get would be something along the lines of, let me zoom out here. And then we'll take a look at some student responses in a moment. But the best model that I was able to get was this. 1 over y hat equals 6.124 minus 0.0655x. That was probably the best model that I was able to get. And if I wanted to justify that, I could say that it gave me the most scattered. Residual plot. In fact, it even gave me an R squared at 95.1%, and it gave me an R at negative 0.975. Those are pretty strong numbers right there. Very strong numbers. I'm going to send you something. I'm about to send you something. Let's send you this file. There we go. Let's see, PDF answers and student solutions. Post. Now, in the student solutions, it's actually where I'm going to go first. In the student solutions, they actually gave an example of what would get a 4 and what would get a 3, I believe. Now, obviously, you're going to want to bring that up on your computer because it's a little bit difficult to see up here. But you can see exactly what the person did to get a 4. This first sample response, the sample 1 response, I believe did get a 4. It does say it at the bottom of the second page in the commentary why they got a 4. But let's just go through it one at a time. Part A, they rounded a bit more than we did. They got $5,170. We get 72. That's perfectly fine. I put in the cents amount. So you can even see in Part B, they did the e to the power thing that we did in order to get that value as well. And then in Part C, yep, they squared that number. And obviously, they rounded a bit more. It's perfectly fine to round. You don't have to do anything other than that. But yeah, that's A, B, and C right there knocked down. Let's see what they said for Part D. Although the correlation coefficients are all quite large, the residual plots all show a distinct pattern, which means that neither fit is the correct one for the data. When I think neither, I'm thinking 2 things, but there are 3 things. I don't know, whatever. I hate English. But yeah, that's exactly what we kind of implied. We would just have to put that down on paper. And then Part E. Oh, interesting. They took a different approach. From the plot of Model 1, it is clear that a better fit for the data would be 2 lines instead of 1. Interesting. The first one would be the least squares regression line on the years prior to 1986. Wow, they took a completely different approach and would be something. Valid. Valid only for these years, while the other one would be the regression line on the years of 86 and later and would be valid for those years. In this case, any pattern in the residual plot would disappear, and the asking price of the 1988 automobile could be determined from the second line of the fit. Now that's really interesting. Let me go back and actually look at let me look at this real quick. I want to look at the Model 1. Model 1. Oh, that's really interesting that they would actually do that. I mean, I've seen people do that before, but Now, mind you, that's not the only way to answer this question. That's just an outside the box kind of solution, but it totally does work. Commentary. A, B, and C show correct calculations. D contains a comment on a pattern in the residual plots. E contains a clear description of how the data could be split into 2 groups, each showing a linear trend, but with different slopes. Score is 4. This is a perfect paper. This is a perfect response, according to the AP grader of the time. Let's look at the next one. Sample 2, I think sample 2, yeah, was also a 4. Sample 2 was also a 4. So this is another way of doing it. Part A, the calculations. I would prefer they put the hat on there, but Model 2, the calculations, they have the correct answer, all the correct work. They're overcoming that. Part 3, same exact thing. Part D, the residuals, which should be random in the best regression, exhibit curved patterns in all 3 graphs. Also, R squared, which should be at least 0.97, 0.98, is 0.946 or lower in every graph. That's debatable. It's really the randomness and the regression, or in the residuals. ln price versus ln year does not correct this. I tried. Okay. And then part E, eliminate from our data pool all cars more than 3 years away from our 1988 car, before 85 or after 91. Then we get a data set with the following graphs sketched from the calculator. Okay. And then the plot of the residuals is, the plot of the residuals is this, which is fairly random. Substituting in our year, we get a price of about $4,448, which seems to correspond to nearby prices fairly well. Okay, numerical calculations are correct. The pattern in the residual is recognized. That's all that really mattered. The solution to improve the fit is to concentrate on the years around 1998, and this is a reasonable way to improve the fit. It's reasonable. It's not the only way. Clearly, the first person had a completely different way, but yeah, that is totally reasonable. All right. The next one lost points. The next one only got a 3. Let's see. Part A. Okay, yeah, they technically do have the correct answer. All right, yeah, and there's the calculation. Part B. That irks me that they did that, but they measured it in thousands of dollars, so technically that is correct. Part C, same thing, yeah. Part D, these models include all of the data. According to the regression equation for the first model, a 1980 car would sell for negative $0.85,000. We know that cars will sell for a minimum amount of money. You can sell almost any car for almost $1,000. You should therefore not include data from cars older than a certain year. Yeah. Clearly, he's not mentioning the clear pattern in the residual graph. We'll see what the commentary says. Part E. It appears that the regression equation for this data would fit better if the data from years 79 to 82 were omitted. Okay, similar idea as the previous guy. If we were to find out prices from cars older than 1984, we would probably find that most of them sold for about $1,000. By omitting 79 and 82, our new regression equation is this, with R squared equal 97%. This is a much better fit than the previous equation. Our new asking price would be about this many $1,000, and that would be closer to the true market value. That's interesting. The calculations are correct. In part E, a good solution is suggested in terms of eliminating the early years. That's interesting. The main weakness of the response is that the pattern in the residuals is not recognized, so the score is 3. That's interesting. I had not thought about eliminating those prices, but I mean, like, yeah, it's like comparing, a little bit of apples and oranges, because, like, that's not us. It's comparing a little bit of apples and oranges just because of the way that the money inflates over time and whatnot. It's really messed up. But yeah, when you eventually get to the very top page, you'll see what they wanted in a complete response. Let me actually see the last part up here. Suggest a new model that successfully deals with the non-linearity of the data. The prime contenders for the model are fit a simple linear model after the first 2 or 3 years are dropped, fit separate linear models to earlier and later data, or fit a model that attempts to model the curvature in the data. For example, fit a quadratic model for all the data. Oh, that's what I did. Good for me. Pat on the back. No, the quadratic model had much more of a pattern. Are you kidding me? Plus, what did I get for an R squared? I got 95%. That's not bad. Yeah, 1997. The entire 1997 AP test is actually available online, all of the multiple choice as well. But we dealt with a multiple choice from 2012, which is a bit more reliable. Okay. Here's what I'm going to do. I have a couple linear regression model problems that I would like you to take a look at. On top of that, and I'm going to remind you of this near the end, I mentioned last class that I wanted to throw an assessment at you in regards to probability. And I am going to do that. I am going to throw a minor assessment at you in regards to probability. But keep in mind, I've altered the directions for what basic multiple choice is. Let me show you this right here. I'll show you the draft that I have going on here. Here we go. I haven't actually attached it yet, but I have here attached is the multiple choice minor for probability. This will count as a minor, but will not be graded as a pure right or wrong multiple choice. For questions that are marked wrong, I will be looking to award partial credit for the work shown or logic used in selecting the answer. For example, if all that went wrong was a small computational error, I do not want to penalize you for it. So please attach the answer selected and the work done if necessary for these problems when submitting this assignment. This will be due Thursday by 7:30 a.m. Email me if you have any questions. When you leave here today, I'm going to be assigning this on Google Classroom. It's a short assignment. I believe it's like 12 multiple choice questions or less. I think it's 12. I got to double check that. But yeah, if you attach your work and you just so happen to get the problem wrong, as long as that work is valid and I can kind of confirm what's going on there, I can award you partial credit for that problem. And I want to do that. Otherwise, multiple choice are just flat out right or wrong. Not a huge fan of that, but that's what we have to deal with on this thing. Okay. I'm going to attach the last two linear regression problems that I want to practice today. It's these two right here. Attach. Linear regression practice. Post. What your task is right now is this. Hold on. Wait for the announcement.
Jayana Bivens, please come to the main office. Jayana Bivens, please come to the main office.
What your task is right now is this. I want you to attempt to answer both of these free response questions. Now, yes, they do say, 12 minutes per. Like, I know we have about 15 minutes left in class. Cool. I want you to try the best you can on these free response questions. First thing on Thursday is we're going to review these two questions. So I want you to get done as much as you possibly can. These two questions are not going to be graded. These two questions will not be graded, but I want you to take your time. I want you to see what you can do with it. Practice using whatever you need to on the calculator. And we'll see where this takes us. Let's get to work. I think one of these questions I may have put on the midterm, but you'll see. Yes, thank you for reminding me about the calculators. When you bring them back, please make sure you disinfect them. Obviously, they're going to be sitting for a few days. We'll see what happens. Now, obviously, there's a few minutes left. I am going to be posting that probability assignment, as I mentioned. I have that ready to go, and it's in my draft thing. I just have to actually click to assign it. But again, I double checked. It is 12 questions, multiple choice. But like I said, if you select the wrong answer, then showing that work can earn that partial credit back, depending on how valid the work is that you have there. That would be absolutely fantastic. Otherwise, if it's wrong, unfortunately it's just wrong. On Thursday, we will pick up with more of this linear regression stuff as we're practicing. And we will hit some other aspects of AP Stat as we race towards that finish line of next week. On Monday is the last day that I will have you right before this AP test. Obviously, we're still going to be reviewing information, but it is going to be a bit more of a hodgepodge rather than just like a focused kind of thing. Like I wanted to focus on probability and linear regression because this is what people end up not remembering the most over the course of time, especially considering some of the things that I saw in some of the review quizzes that we've done in the past. So you have a couple minutes to go until that bell. I'm going to give that reminder for anybody in the chat. If you have not left a comment, please make sure that you do so. I do see the 1, 2, 3, 4, 5 comments that people have left thus far. That is fantastic. Thank you for that. Yeah, and we will kind of wrap this up. I was going to show this earlier, and I completely forgot to. I thought it was hilarious. But my son, in the last 26 days of the school year, my son's class is doing the 26 letters of the alphabet leading up to the last day of school. And so yesterday was C. So it's like, the 26 days and 25 days and 24 days. C was labeled Crazy Hair Day. So this was, if I could actually bring this back over here and flip this over here, you can see how amazing his crazy hair was. Look at that. Look at that crazy hair. That is just amazing right there. He was so proud of that. You wish you had crazy hair like that. But anyway, I digress. That's my son. That's what he does. I don't have the picture, but my wife is going to send it to me at some point. She said that my daughter tried to recreate that scene in Frozen 1 where Anna and Elsa are on opposite sides of the door, where she was sitting against a tree with her Elsa doll on the other side. She did that completely on her own. I don't know how she thinks of this stuff, but I'll have to show you that picture if I get it eventually. But anyway, that's that. Bell's going to ring in approximately 29 seconds. So just wait for that, and we'll see what goes on. Some people are doubting my accuracy of 29 seconds. You see, you'll see. See, told you. Just saying. Whatever. Thank you, too. See you guys. Thank you. See you guys. Bye-bye. Have a good one. I got to get off that live stream. Wait.